Good evening, all. My screen is visible to you or not? Anyone, please?
Yes, sir, it's visible.
And this particular jam file, this is also visible, no? This one?
Yes, sir.
Okay. So, shall we start?
Yes, sir. We will start.
Okay, thank you. Good evening, ladies and gentlemen. And today, I think we are starting a new MOOC course on the Internet of Things. So, my duty is to address you with a very brief idea of how to proceed with or how to develop an Internet of Things strategy. So I think we can wind up the session within maximum of 45 minutes. In case if any clarification from my side is required, then we will discuss it. And this is what is the title of my presentation, Journey Through the Internet of Things IoT from Concept to Reality. This is a breakup of my session today, and let me go through each one. First of all, we'll see what is meant by IoT and how it will be or it can be differentiated from a normal embedded system. And then after that, we will see the roadmap to this particular IoT scenario, followed by the characteristics, applications, and a couple of use cases are also shown, very fundamental level of use cases. And then as you might be knowing, different types of IoT is are available based on the what you call the different types of strategies or different type or the nature or the application areas. And then we'll see the basic concept of Internet of Things, followed by the architecture. And after that, some of the communication scenarios are also employed that will be seen next, followed by the challenges, future, and conclusion. And this is a breakup. Let me straight away come into what is Internet of Things. So I don't like to make it a unidirectional section. I would like to make it a bidirectional communication strategy. So I request the gentle responses and humble response from you, my dear students. So anyone in this particular virtual meeting can be able to differentiate embedded system and Internet of Things. And any idea about, can anyone talk? Anyone talk? And what is embedded system? Any idea? Whatever be it is, not at all an issue, it's wrong or right, no, at all an issue. We'll proceed in that way. So anyone can answer. Just your understanding about embedded system. Anyone can. Hello. Am I audible? Yes, anyone can. I think many of the students or majority of the participants are from first year, and you are very passionate electronics and communication budding engineers. And please do answer. I told you, no
Sir,
issue. But please, who is talking now? Your name, please.
my name is Gayatri KB.
Gayatri KV. Okay, Gayatri. Please, what is your understanding about embedded system?
Embedded system are specialized computing systems designed to perform dedicated functions or tasks within a larger system.
Excellent. Can you please list out me an example of a particular embedded system? Any example? So many home appliances are available. So many electronic gadgets are available. Any example?
So PIR passive infrared.
Ah, passive infrared, sensor-based system, or okay, no issue. Anyway, excellent definition of given embedded system. and that particular embedded system is nothing but which is a system or electronic system that is specifically designed for a specific task, as Gayatri said. And then anyone give me an idea about IoT? IoT. And in this particular slide itself, so many definitions are provided here. Can anyone give me an illustration about IoT? And then what I wanted to convey you is that we'll have to make an exact differentiated between embedded system and IoT. And then we will come into the picture of our discussion. Anybody? IoT. Excellent. Devices are connected through internet. Okay. And then next thing is that we'll have to, prior to starting this particular session, we'll have to make an exact differentiation among embedded system and IoT. Anyone in this group is possible to distinguish between embedded system and IoT, or shall we call all embedded systems are IoT or IoT devices or IoT systems? Shall we call all embedded systems as IoT systems? And if you are unable to talk in a virtual audience, you can even type it in the chat box, no issue. Shall we, my question is, please listen me, shall we call all embedded systems as IoT systems?
No, sir. Some embedded systems won't be having internet connectivity, so we can distinguish it as IoT.
Excellent. So my task is easy, and is it visible for you, this particular jam file? This board is visible?
Yes, sir.
Okay. So, and majority of the people are able to differentiate that embedded system and IoT. Even then, let me come to the picture of a small embedded system. See, assume this is a very small block schematic of a very fundamental level of embedded system. The term depicting that ES is nothing but the hardware system, and D is nothing but a display device. So the objective is to design and make an embedded system which is capable to display the room temperature. That is the objective. Hope it is clear for you. The objective is to make an embedded system that is capable to display the current room temperature in a local display device. Say for example, assume this display device is nothing but which is a normal 16x2 LCD display, and that is the task. And anyway, by using that electronic facilities available, or by after doing some kind of surveys, and we have chosen up the hardware components as well as the microprocessor element and all that board and related things under this particular embedded system. And that is the task. And after that, at the end of all this process, now I am in a position to display the room temperature. So this time I can say that this components or this particular system inside this big block can be called as an embedded system alone, not an IoT system. Now, after successfully implementing this, one of my friends had approached me and he has directed me to design another system that would be capable to display the same display which is currently available at that LCD display into his or her smart gadget. Clear ആയെന്ന് വിചാരിക്കുന്നു. ഇനീഷ്യലി നമ്മൾക്ക് വേണ്ടിയിരുന്ന റിക്വയർമെന്റ് ആദ്യം ചെയ്തു. സാധാരണ ഒരു നോർമൽ എംബഡഡ് സിസ്റ്റം, ആ എംബഡഡ് സിസ്റ്റത്തിൽ നമ്മൾക്ക് ചെയ്യേണ്ട ഡിസ്പ്ലേ ചെയ്യേണ്ട റൂം ടെമ്പറേച്ചർ എന്ന് പറയുന്നത് നോർമലി ഒരു LCD-യിൽ മാത്രം മതിയായിരുന്നു. അത് കഴിഞ്ഞ് ഞാൻ ഇങ്ങനെ വെച്ചപ്പം എൻ്റെ ഒരു ഫ്രണ്ട് വന്നിട്ട് പറഞ്ഞു, അത് പോരടാ, നമുക്ക് ഈ ഡിസ്പ്ലേ ഡിവൈസ് മാറ്റി അതവിടെ ഇരുന്നോട്ടെ, മാറ്റുകയും വേണ്ട. എനിക്ക് എൻ്റെ സ്മാർട്ട് ഗാഡ്ജറ്റിൽ ഈ ടെമ്പറേച്ചർ കാണണം. Now that task becomes little bit tedious for me. അപ്പോൾ ഞാൻ എന്ത് ചെയ്യും, ഈ ഡിസ്പ്ലേയിൽ വരെ, അതായത് in this particular system the controller to that display, by taking a wire or a simple connection, my task is over. Now the scene changed. That in the sense I have to display this specific room temperature in my electronic or smart gadget, which is remotely located. And also I have to store this particular information wirelessly to another data entity which is remotely located. For our namesake, we all are called that particular remote located data storage as the term cloud, which is called as cloud. And then my task, this particular data, temperature data, to that cloud, and from that cloud, whenever I wanted to take that data at my smartphone, that to be given to this particular smart gadget again. Now this is a complex task, and smart gadgets, every time to get that data, as you might be knowing, an internet connection is required. Now that things are nothing but all the hardwares, including that hardware component as well as the data which is arrived at that so-called room temperature data, which is arrived at that so-called display devices, is currently being monitored by the smartphone of my friend, and my friend is staying at a remote location from this particular embedded system. So now everything is incorporated. Previously it was a very simple embedded system. Now we have incorporated internet facility. Through that internet facility, we are remotely monitoring that particular current room temperature display in a smart gadget. Then it becomes something related to internet. By internet we are what you call that, controlling certain kind of things. Now this whole entity can be called under the umbrella of an internet or internet of thing related system. Now I think that very fundamental concept is clear for you, and this is what is a very fundamental differentiation among an embedded system and an IoT related system. If any kind of internet facility or that internet storage related informations are being stored, then only that particular system will become internet of things. Now I think that particular concept is clearer for you. Anyone, please? Concept is clear? Difference between embedded system and an IoT based system. I think now it is clear.
Yes, sir, it's clear.
Yes, sir.
Then I'm coming into the first slide of my presentation, and a couple of descriptions are clear given here. And the first statement itself says that internet technology connecting devices, I told you know that, machines and tools to the internet by means of wireless technology. That in the sense, from the physical device to the virtual entity, whatever be, whether it is IoT cloud or whether it is IoT remotely located smart home appliances or smart gadget or whatever be the smart device, and they all are controlled by using wireless technologies. Not wired scenarios are possible there. Even then we rely on wireless technology. Okay, and then and the same definitions are shown in the next couple of statements. I am not going to read it again. And similarly, if anybody wanted to get in a clear cut picture about the definitions which I have given here, please go through these references. And then again another thing is here, connecting inanimate devices over the internet without human intervention. That is another peculiar speciality of internet of thing or internet of connected devices. Why? Because even then we have incorporated all the facilities by remotely, and still then will have to require any kind of human intervention. That is a hectic process. So without human intervention, if we can achieve, that is a very what I can say, specific and excellent task in the IoT related devices. That kind of human intervention is very, very, very little. We can say that without human intervention, these kind of IoT connected devices are possible. And then everywhere prior to starting a new technology, we'll have to see the timeline or the roadmap of that particular information or the particular concept we are progressing with. So here you can see that in 1989, the first IoT device is created. You can see that particular one in the background itself. And from there it has started and at 2022, as per World Economic Forum names, and they have stated that this IoT is one of the three most impactful technological advancement. Many other technologies are there. As we are currently focusing on this IoT, as per this particular World Economic Forum, we can say that it is one of the very, very, very booming technology in days. And see so many other, you can see that so many other timeline I have shown here, and please go through. These all are self-explanatory only. And in that very, very, very famous one is nothing but in 2007, first iPhone was launched. And this is also shown here. And then and here nowadays we can see that majority of the students, I told you, first year students only, and you can see what you call that the evolution of that connected devices in the sense the devices that are connected by means of internet or by means of any communication, and that communication may be wireless or wired communication scenario. In wireless and wired communication, so many different types of options and protocols are also available. See here, and the first thing is nothing but ATMs is also a kind of what you call that connected so many strategies inside that. And please do think over that. You should also get an idea about and what are the connecting or connective devices inside that particular ATM machine. And after that, internet is there, and then smart meters come into picture, and then digital location also came into picture, and then so many smart healthcare related things are there. And nowadays, smart vehicles are also launched, and now so many smart cities are in our country itself, in our place itself, not in our place, in Bangalore and all other places. So many smart cities are there. And another use case or the another thing is nothing but which is a smart dust related application. And these are some of the what you call that important specific evolution of connected devices. And then I'm coming across that summary of IoT history and evolution. And this is also self-explanatory only. If anyone wanted to get a clear picture about how that particular evolution happened and how the progress of that particular IoT in each decade, that is clearly given in this particular slide. And here, and the last box state that at the end of 2030, Internet of Video Things. In that, the number of cameras in the world would be between 10 to 100 billions. And now also, so many billions of billion IoT connected devices are available. In the next slide itself, I'm giving you with an idea about the year-wise progress of the devices that are connected under the umbrella of IoT. So anyway, this is also self-explanatory. And this is another use case here. The distribution of IoT market by 2025 is listed. Here you can see that so many areas are proven here: healthcare industry, and similarly retail industry, and then security related industry, and then transportation, and manufacturing, and at last others. And these are the major sectors where the predominant contribution of IoT is being taken place. Of these sectors, you can see that in the manufacturing industry, more than 40.3% of the IoT domination has been taken place till date. And similarly, you can see the progress. In the case of healthcare also, around 30.2% of the contribution or distribution of IoT market. And next, come down to that other spaces here, around 10% of the distribution has been happened. And similarly, retail, security, and all other kind of sectors also equally contributing. Now, another one is nothing but based on the report by a forecasting reputed forecasting agency, and you can saw that or you can see that in 2015 around 15.5 billion devices are already been connected under the umbrella of IoT, and it has increased to 30.7 billion in 2020, and they are expecting that at the end of 2025 around 75.4 billion devices are get connected or will be connected under the umbrella of this big IoT scenario. So you can even see that, and they have taken a graphical representation in the form of a graph chart from 2015 to 2025, and see that roadmap. The devices are being increased very hectically. It is increasing from 15.41 billion devices at 2015 to 75.44 devices is expected to arrive at the end of 2025. And this is what is a very fundamental things about that IoT. I've given you with a definition and the evolution and the current market trend, and where that IoT sectors are currently focusing. And now we are coming into the specific characteristics of IoT. And a couple of characteristics are listed over here. And the first point is nothing but efficient. Efficient. Anyone say, and what is a efficiency parameter meant in IoT? Efficiency. What does it mean? Efficiency. Anyone? So many are there. Please, efficiency in terms of IoT. What is meant by efficiency? Efficiency. Any real examples are possible? Let me call.
Sir,
Pardon, please.
sir, it's like how much
Your good
speed
name.
or
Your good name.
instantaneously the thing is working. Sir, my name is Jonah Jacob. I'm
Okay. I
S1
know.
student.
No. Jonah. Okay, please, Jonah. What is your
So is it
understanding
like
about the
uh,
efficiency of
okay? So
IoT?
is it like just how speedily the data is transferring, or like for example, if we have a GPS tracker device, so is it especially designed for children? So is it like how if the child is gone missing, how fast does the thing is transferring the message to the parent device or something like that?
Okay. Very good, Jonah. Very good. And that is one of the aspect of the term efficiency in IoT. And you have exactly said that speed of communication. Other than that, in electronic communication scenario, we'll have to address so many other parameters. Say, for example, power optimization, and we all are like to consume very less power, whatever be the device. If it is a mobile phone, if it is a laptop, if it is any other kind of gadget, if it is our if it is a vehicle, in that vehicle we all prefer what do you call that, a very good mileage. So efficiency in the IoT is nothing but it is capable to provide low power, low bandwidth, very better computational capacity, and then reduce data transmission complexity, etc., etc. So on that kind of aspect, the IoT devices are very excellent efficiency. And the next point is nothing but scalable. Scalable in the sense, and scalability is again another important parameter of any kind of electronic automated system. And this is nothing but ability of a device to handle a growing number of device data and usage without compromising what you call performance parameters. That in the sense, in the case of IoT, and freely upgradation is possible, and we can easily upgrade it without compromising. And what you call that, if much more parameters are added with that, even then the response time or the throughput of that particular parameter will be retained as the previous case. So efficiency and scalability are and couple of characteristics of that IoT. And similarly, another parameter is unambiguous naming and addressing. That in the case, different type of naming strategy and addressing strategy, unique naming and unique identifiers are also possible, and that all are one of the another category, sorry, characteristics of IoT. And similarly, I told you in the beginning itself that and remote monitoring and control is possible. And if my embedded related system is locating at one place, and if I am sitting in another country, even then I can access, monitor, or control the entity by using the smart gadget which is locating remotely. So that remote kind of monitoring and control and process is also possible. And then intermittent connectivity, seamless connectivity is one of another characteristics of IoT. And then in case any kind of real-time feedback to be given back to the embedded system based on the criticality or based on the requirement, and that is also possible in the case of IoT devices. And then another one is nothing but if we wanted to upgrade the system, and self upgradation is also possible. The last point is nothing but data analytics, and we all are, and basically what do you call that, monitoring and observing the data usage of our smart gadget when it consume or when it is coming to that online daily. And in majority of the phone that that option is available, and we all are looking into that data consumption. In that way, many of the platforms or many of the tools are available for performing that particular data analysis or data analytics in the case of IoT. So, and these are couple of vital characteristics only. So many other characteristics are also possible in the case of IoT related system. And now I'm coming across the applications of IoT. Here a couple of terms are listed, or couple of use cases are listed here. And the first one is smart cities, and the second one is smart manufacturing, building and home automation, healthcare, automotive, and wearables. So let me take the case of a healthcare application. Healthcare application. Can anyone and list out or give me an example or use case of a healthcare application of IoT? I think Rion Thomas is there. Then Godwin, Surikiran, are you there? Surikiran, if you are in a position to turn on your mic and tell me an application where that healthcare sector of IoT played a major role, or plays a major role. Surikiran, are you there? No. And then Anna. So anyone, healthcare industry, please suggest an example or application area in the sector of healthcare, IoT.
Sir, pacemaker.
Pacemaker is exactly, I cannot agree with that. Okay, and please do elaborate that so-called feature of the health, pacemaker that you have mentioned now. Pacemaker. Anyway, the concept is very clear, very concept is very clear, and please do think a little bit and tell me. Healthcare, pacemaker is here, and the patient or the human being or a patient who is not at all capable to what you call that, his heart is having or he is having some of the cardiovascular diseases, and some of the cases the cardiologist may advise to put a pacemaker, and after that pacemaker is not that particular pacemaker alone cannot be called as an IoT devices. But if you could add something in addition to that, or in line with that particular pacemaker, then we can call that system as an IoT system. And can you elaborate
Yes.
it a little bit?
Like kind of nowadays more technologies are building. That's why wireless like connections are being done for pacemaker. So if anything happens to the person who is using the pacemaker,
Exactly.
and if we are not getting any signal or something, we can find him or her
Okay.
like kind of a GPS tracking or something. Those technologies has been brought up,
Okay,
right?
okay, 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 okay. And so many researches are being progress in that particular area. So, and for that first year students, I think, and take the case of that pacemaker itself. In that pacemaker, if and pacemaker is basically what you call that artificially making that cardiac related pulses, and even then some kind of problems are there, or the doctor who is sitting in another state or in another location, is he or she wants to monitor the progress of the heart rate or the heartbeat of the patient who has equipped with that particular pacemaker, then it becomes an IoT related system, because pacemaker is installed in a patient, and that particular pacemaker is properly working, and then that particular data information is going to be sent wirelessly with the help of what you call that cloud platform, and from there that information is stored, and when a doctor or a patient who wanted to observe or monitor that particular information in a system which is remotely available, then that entire entity can call as an IoT related system. Similarly, so many other areas are also there. And someone has what do you call that given a message as wearable devices. So this is the last sector. So many researches are currently being nowadays. We all are wearing smart watches. So many
Sir,
parameters are. Hello.
sir, may
Tell me.
I ask a doubt? Sir, there are some chips, right, which is specifically designed for knowing the medical history of a patient, right? So, do it come under this?
Exactly. See, I think you are not in my first explanation how to differentiate an embedded system with an IoT related system. Exactly. If that chip is going to what you call that impart inside a human body, and they are taking the data, and by using any kind of antenna or related wireless technology, they are going to transmit it to the external world, and they are storing it somewhere else. If that is a scenario, obviously we can call that is an IoT related system or IoT
Okay, sir.
based system. Okay. If no, and in some other scenarios, let me what do you call that, elaborate it little bit. And if some of the chips they are going to impart in the human body due to monitor some of the parameters, are not capable to send that particular information to the external world in real time. In that case, and they are storing that particular information in a memory or a device which is kept inside itself, and whenever we wanted to process it, we can take it out, and we can what do you call that, insert it in some devices, or thereby we can note it, and that is not at all comes under the category of IoT devices.
Okay, sir.
Hope it is clear for you. Okay. So, and these
Yes.
are some of the sectors where what you call that IoT plays a very good role. I think not now time is 7:50, so I'm not going to what you call that spare much more time on this particular application side. And these are a couple of examples I have shown here, and few of the cases are already I have given to you. And in case if anybody wanted to get a clear idea, I can tell you. Else, we will skip this slide and move on to the next slide. Okay. So, different types of IoT. Here you can see that around five types of IoTs are possible. This is nothing but based on the application environment or application strategy or scenario. and there are different types of IoTs are possible under the big umbrella of the generalized IoT. And we have, based on the application and based on the structure of the entity where we are using, and so many different types of IoT standards are possible. So let me come across one by one. Consumer Internet of Things is again Internet of Things, and here I have marked it as IoT for consumer applications and devices. And these are a type of IoT, consumer Internet of Things. Here, the devices are intended for consumer applications. Say, for example, smartphones, wearables, smart assistants, home appliances, etc. comes under this particular category. Clear? And similarly, commercial Internet of Things, another interesting factor, commercial Internet of Things. See, you can see that personal and home environment applications, say for example, commercializing supermarkets and couple of stores, hotels, and then healthcare facilities. They're all, and a couple of requirements are there for that IoT, and they all are come under the small umbrella of commercial Internet of Things. Similarly, nowadays in the application itself, I have given you a clear picture that nowadays majority of the industries are smart in nature. Okay, so that is nothing but industrial Internet of Things, and here also they're augmenting existing industrial system. Say, for example, assume or suppose a case of a what you call that a sandwich production industry. Here it's a very hygiene place. So many what you call that sandwiches are being made in an hour. And assume the manager or the patient who is taking care of that particular shop is locating in a remote location, and he wants to what you call that verify the process that is happening inside that particular industry. So if everything is remotely connected by using that IoT system, that real-time information about the production of that sandwich which is happening inside that so-called industry can be available for that patient who is remotely located. And similarly, infrastructure Internet of Things, and they are related with what you call that smart infrastructure development. Some of the cases, bridges, railway tracks, and on and offshore wind farms, etc. There all are this particular IoT played a major role. So in the case of that smart farms and in bridges, etc., the people or the technician can give that or share his expertise remotely who is working on particular area. And similarly, and there is another strategy which is nothing but Internet of military things, battlefield IoT, and which is അതിന് battlefield IoT എന്നാണ് പറയുക. അപ്പം ആ particular entity വരുന്ന സാധനം, and we have to connect that particular ships or planes or tanks, soldiers or drones in a communication line, and then we can call that particular entity as Internet military of things. So many things are there. Internet video of things are there. Internet medical things are there. So many. Internet of health of things are there. Anyway, so many descriptions are possible, and these are some of the different types of IoT based on the application strategies. And now let me come into the K concept of IoT. That in the sense, and here I have what you call that highlighted couple of points in red. They are connectivity, data collection, data exchange, automation, and intelligence. That in the sense, an IoT system should be capable to provide sufficient connectivity. Connectivity in the sense that connectivity maybe we can achieve that connectivity in different form. Obviously, it is a wireless strategy. In that wireless strategy, so many communication protocols are there. Maybe sometimes it is short range communication, sometimes it is long range, sometimes it is a medium range communication, and that kind of connectivity issues should be, and that IoT system should be capable to and provide adequate connectivity. And similarly, it should be capable to provide sufficient data collection. That in the sense, sensors are a vital part in that IoT devices, and we'll have to connect that what you call that proper data using various sensors, and that physical data collected should be conveyed into digital form, and for that data exchange to be happened, and in prior to that data exchange, and that data processing will be taking place at a microcontroller platform, and in case, and we'll have to take some kind of automated decision making to be happen there. That in the sense, if the room temperature of a particular room is above 26.3, assume, and that is the threshold I have set up. Whenever that 26.3 സെറ്റിന് മുകളിലേക്ക് പോകുന്ന സമയത്ത് I am going to reduce that AC limit to 23.3. അപ്പോൾ 26-ന് മുകളിൽ എപ്പോഴെങ്കിലും റൂം ടെമ്പറേച്ചർ പോയാൽ എൻ്റെ ഡിവൈസിനെ ഓട്ടോമാറ്റിക്കലി ഐ ഹാവ് ടു സെറ്റ് ഇറ്റ്സ് ടെമ്പറേച്ചർ ബാക്ക് ടു 23. Okay, and then for that achievement I have to provide some kind of intelligence. These are the key concept which is come under that IoT. They are capable enough to provide that connectivity. Similarly, all other points listed here, and that IoT devices will be capable to provide these facilities. And now, and these are some of the connectivity layers, and a good idea about these connectivity layers will be given to you upon a couple of slides. Now, and this is nothing but this is a fundamental architecture of IoT. See, and you can see that there are 4 layers are possible. ഞാൻ പറയുന്നുണ്ടെന്ന് മനസ്സിലാവുന്നു വിചാരിക്കുന്നു. 4 layers you can see from the sensing layer, network layer, data processing layer, and application layer. So this is a top to bottom approach. That in the sense, this is a layered architecture. Sensing layer, above that the network layer will come into picture, above that the data processing layer, above that application layer. Okay, so the first 3 layers are mandatorily required to make an IoT system. But the third one, application layer, this is not at all mandatory. But in nowadays, so many systems are based only on, or they are having that facility of application layer capability. Okay, so somebody is asking you related what are the different layers possible in a very fundamental IoT structure. You can say that very fundamentally there are 4 layers are there. A bottom to top approach. Sensing layer is a foundation. Above that, network layer, data processing, and application layer. So based on the requirement or the scenario change happens, so many other layers are also or can also be introduced along with this particular architecture part. So let us see a brief description of each layer one by one. The sensing layer is nothing but, anyway, sensor is a vital part, I told you, no, and sensors or actuators, so that similar devices plays a major role. They are sensing the physical entity, and that equivalent electrical information will be processed by the microcontroller or the powerful processor which is locating at this particular layer, and they are processing it and sending remotely. അപ്പോൾ ഈ സെൻസറിൽ കാണുക പല തരത്തിലുള്ള ഈ ലെയർ, സെൻസിങ് ലെയർ എന്ന് പറയുന്ന ലെയറിൽ അത് സെൻസേഴ്സ് ആവാം, ആക്ടിവേറ്റേഴ്സ് ആവാം, അതേപോലെ മറ്റ് പല തരത്തിലുള്ള ഡിവൈസസ് ആവാം. അപ്പം ഇതെല്ലാം സ്മാർട്ട് സെൻസേഴ്സ് ആണ് IoT-യിൽ കൂടുതലായിട്ടുണ്ടാവുക. അപ്പോൾ സ്മാർട്ട് സെൻസേഴ്സ് ഇൻ ദ സെൻസ് അതിൻ്റെ പവർ കൺസംപ്ഷൻ കുറവായിരിക്കും, അതിൻ്റെ സൈസ് കുറവായിരിക്കും, അതിൻ്റെ ഡേറ്റ റേറ്റ് കൂടുതലായിരിക്കും, അതിൻ്റെ ഫ്രീക്വൻസി ഓഫ് ഓപ്പറേഷൻ, ബാൻഡ് വിഡ്ത്ത്, കപ്പാസിറ്റി, അങ്ങനെയുള്ള കാര്യങ്ങളൊക്കെ when compared with the previous kind of old conventional sensors, they are very capable. അപ്പോൾ ഈ സെൻസറിന്റെ ഇൻഫർമേഷൻ എല്ലാം നമ്മൾ കോംപ്ലക്സിറ്റി അനുസരിച്ച് അതിനെ അക്വയർ ചെയ്തു, ആൻഡ് ദെൻ അതിലെ ഒരു മൈക്രോ കൺട്രോളർ ഒരു പ്രോസസർ റിലേറ്റഡ് സിസ്റ്റത്തിലേക്ക് കൊടുത്തു, പ്രോസസ്സ് ചെയ്തു, ആൻഡ് നൗ വി ആർ ഗോയിങ് ടു ഡിജിറ്റലി ട്രാൻസ്മിറ്റ് ദാറ്റ് ഡേറ്റ. ഓക്കെ, അപ്പം ഇതിൽ to remotely transmit that particular data, so many platforms are available. They all are come under the network layer. You can see the symbol of Bluetooth, and then Wi-Fi, a virtual antenna, and then cloud. So many things are shown here. And now again they are coming into another entity. This is nothing but a data processing layer. Assume, and this particular data processing layer is located remotely from that sensors by using what you call that short communication or wide communication or medium communication gateways. We are making it arrive at that processing unit there by using different IDE or the softwares or SDK which are provided or supplied by the vendors. They are processing that information, and then based on the requirement, we are what you call that sending that particular information to different users or different entities, like a smart watch, and then smartphone, a smart vehicle is there, and smart home is there. So, and this is what is the different layers they are present in the architecture of an IoT. Hope this is clear for you. Any elaboration is required anyway, and these sections will be given to you in the upcoming weeks by other resource persons in a little bit detailed manner. And my duty is to give you with a very fundamental idea about how that IoT works. I think this is clear for you now. Shall I proceed to next slide? Anyone, please? Anybody, please? Shall I proceed?
Clear, sir. It's
Okay.
clear.
See, and this is another one, another version of that architecture of IoT is on here. That in the sense, device hardware. Basically, this particular device hardware is there in that sensing, networking, and data processing layer. And to write the code, relevant code required to process that data, we require a device software. And from that point, we'll have to send that particular information to the cloud platform. So various communication protocols are required, and in that cloud platform we are storing, we are processing, and we are monitoring that data. And so many very reputed, well-known, commercially available cloud platforms are available. I've included the information of that so and so clouds in a couple of in after a couple of slides. See, in platform wise, I can say that these are the possible platforms in the case of IoT. I think the same has been given in the beginning itself, and we'll have to develop the required hardware. So the platform which comprising that microcontroller, microprocessor, sometimes it may be SoC, sometimes it may be a system on module, etc., etc., and that all are comes under the category of hardware development platform. So to make a full-fledged IoT device, all these platforms are mandatorily required from the hardware platform to that cloud platform. But the last one is not mandatory required. Based on the application or based on the complexity, only that cloud platforms are required. Until or unless otherwise, the rest of the four platforms are enough. And that app, next one, that app development platform, this is nothing but anyway, and the students who are pursuing the project or mini project or any kind of hobby project using embedded system. Say for example, I am having a PIC microcontroller as the master processor with me, and then we'll have develop the required code to control that action. So to develop that particular code, we require a kind of software, and that particular software is known as IDE, under the term Integrated Development Environment. Say for example, I told you, and the microcontroller I want to use is nothing but PIC. So the IDE basically, one of the IDE basically used for that particular development is nothing but maybe Keel we can use, and similarly Ride is a very good platform, and so many platforms like IDEs are available. In that IDE, we are making the software code, and that is going to control that IoT related structure. And then connectivity platform, I already told you that so many platforms are available, and another slide will give you with a very brief idea about what are the connectivity solutions possible. And then analytics platform also I have given you with, and so many analysis tools are there, softwares are there, and real-time analysis are also possible. And now I told you, and this is an interesting plate. I think Shabari sir will be going to give you a brief, not brief, in-depth idea about all that connectivity platforms which is available in IoT technology in the 4th week, I think. So see, there are 3 categorizations are possible. The first one is short range communication. Short range IoT solutions. That in the sense, in that particular context, the information to be conveyed within a very limited range. And the next category will have to convey or will have to transfer or transceive that information in a medium range. And the last category is nothing but a long range IoT solution. Let me explain and one by one and see the case of Bluetooth. Bluetooth is available in everybody's smartphone nowadays. And anyone tell what about the possible range of communication distance of the Bluetooth? Anyone in this group? Not exact one. Any idea? Is it kilometer or it in meter range or it in millimeter range or it in centimeter range? Any idea? Anyone? Bluetooth.
Meter range, sir.
Meter range only, very short range. So in that context, the connectivity solution or the wireless technology we are going to transfer that information or transfer that information is nothing but Bluetooth. Similarly, RFID tags, and you all are doing shopping daily, I think, and RFID tags or RFID scanners or RFID cards are available, and these two are the best suitable example for connectivity platform. Similarly, in the case of medium range, and you can see that Wi-Fi is available for that what you call that internet related for both voice and video related thing, and Wi-Fi is another solution, and Thread is also a communication strategy provided by another agency, and similarly Zigbee. Anyone know what is the role of Zigbee in IoT platform? Zigbee is a communication strategy put forth by Zigbee Alliance, and this is a particular kind of protocol platform for wireless communication, and that Zigbee module itself comprises a powerful microcontroller. Microcontroller in the sense an ARM-based microcontroller is there inside that Zigbee, and minimally 128-bit encryption standard is provided by that Zigbee, and it's a kind of small chip. Is a protocol stack which is used for wirelessly communicating that information, Zigbee, and it is operating in 2.4 gigahertz ISM band. And similarly, come to that long range communication, you can see that NB IoT. NB is nothing but NB stands for narrowband, and then LoRaWAN. WAN is wide area network. LoRa is nothing but low power, long range radio communication. And then LTE is long term evolution, and this particular category is related to that mobile communication, long term evolution category mobile 1, and that Sigfox is another company. They are also providing a particular kind of wireless connectivity solution in long range IoT sector. Okay, and these are basically the 3 segments of connectivity platforms available, and I think now that part is also clear for you. And in case if anyone wanted to get a clear picture about these connectivity platforms, please do get into this particular reference. I have given you the hyperlinked information. You can even get into that particular website or that particular e-resource which is currently available. And then I told you, and there are so many cloud platforms are there. Cloud platforms. Cloud എന്ന് പറഞ്ഞാൽ എനിക്കറിയില്ല, നിങ്ങൾക്ക് ഫസ്റ്റ് ഇയർ സ്റ്റുഡൻസ് ഇവിടെ ഉണ്ട്, നിങ്ങൾക്ക് അതിനെക്കുറിച്ചുള്ള ഒരു അത്ര കണ്ട് ധാരണയുണ്ടോ എന്നുള്ളത് അറിയില്ല. ഈ ക്ലൗഡ് എന്ന് പറഞ്ഞാൽ മനസ്സിൽ വിചാരിക്കണ പോലെ ഇത് ശരിക്കും മേഘമാണോ എന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ മേഘം അല്ല. അത് നമ്മൾ വെർച്വലി കൊണ്ടുപോയി ഒരിടത്തും ഒന്ന് സ്റ്റോർ ചെയ്ത് വെക്കുകയില്ല. ഈ ക്ലൗഡ് ഇൻ ദ സെൻസ് ദേ ഓൾ ആർ വെരി പവർഫുൾ ഹാർഡ്വെയർ ഡിവൈസസ്. നമ്മുടെ കയ്യിലൊക്കെ ഇരിക്കുന്ന ഈ ഹാർഡ് ഡിസ്കും അതുപോലെ പെൻഡ്രൈവും ഒക്കെ പോലെ റിമോട്ട് ലൊക്കേഷനിൽ പല പല പ്ലേസുകളിൽ ഇരിക്കുന്ന പവർഫുൾ ആയിട്ടുള്ള ഹാർഡ്വെയർ ഡേറ്റ സ്റ്റോറേജ് ഡിവൈസസ് തന്നെയാണ് ക്ലൗഡ് പ്ലാറ്റ്ഫോംസ്. അപ്പൊ ആ ക്ലൗഡിൽ ഇപ്പൊ നിങ്ങൾ മൊബൈൽ ഫോൺ ഒക്കെ യൂസ് ചെയ്യുന്ന ആൾക്കാരാണെങ്കിൽ അറിയാം, ഈവൻ ഇൻ അവർ ഗൂഗിൾ ഇറ്റ് സെൽഫ് ഇപ്പം നവഡേസ് 15 GB ആയി എന്ന് പറഞ്ഞൊക്കെ മെസ്സേജ് നിങ്ങൾക്ക് വരുന്നുണ്ടാവും. അത് ക്ലൗഡ് ആണോ എന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ, ബട്ട് അവർ ഇൻഫർമേഷൻ ഈസ് remotely storing in a hardware device, but virtually we can have the access by using the required login credentials. അപ്പോൾ അതൊക്കെ ഈ ക്ലൗഡിൻ്റെ സെക്യൂരിറ്റി ആയിട്ട് ബന്ധപ്പെട്ട കാര്യങ്ങളാണ്. അതും അതിനെക്കുറിച്ചുള്ള കാര്യങ്ങളും അതിൽ സെക്യൂരിറ്റി ആസ്പെക്ട്സ് എങ്ങനെയാണ്, ഹൗ ദാറ്റ് ഈസ് ദെയർ എനി പോസിബിലിറ്റി ഓഫ് ഗെറ്റിംഗ് ഹാക്ഡ് ദാറ്റ് പർട്ടിക്കുലർ ഇൻഫർമേഷൻ, and hardware credentials are possible, and how their credentials are being hacked, and that kind of information will be covered up in the upcoming weeks by many other resource persons. And so that cloud platforms are nothing but so many other entities in the sense, and couple of names provided here are very familiar for you. Say for example Google, and this symbol is very familiar, and this particular symbol is very familiar, and this is very familiar for you, and this symbol is very familiar for the electronics and communication engineers, and this term is also familiar, and they all are nothing but the Google is also providing a virtual cloud data storage platform, Google platform, and then this Azure is nothing but another virtual cloud platform provided by Microsoft, and AWS is Amazon virtual storage, Amazon Web Service, and this is another cloud platform, and similarly IBM Watson, then Oracle, Cisco, all are providing so many cloud platforms. Some of these particular entities are providing that what you call the data storage phase virtually, fully free manner, but in some other cases to use that particular data will have to pay to that particular entity. Okay, so and these are some of the very famous cloud platforms. In case if you wanted to get a clear picture and some more details about the various cloud platforms, and please go through this particular reference. And then this is challenges in the sense, and there will have to address something more. Say for example security and privacy, and data security and data privacy. ഇപ്പോൾ എനിക്ക് എൻ്റെ ജിമെയിലിൽ ഒരു ഇൻഫർമേഷൻ കിടപ്പുണ്ടെങ്കിൽ അത് മറ്റാരും അടിച്ചോണ്ട് പോവാതെ, അല്ലെങ്കിൽ മറ്റാരും അതിനെ ഹാക്ക് ചെയ്യാതെ, അത് എൻ്റെ കയ്യിൽ തന്നെ എൻ്റെ പാസ്വേഡ് വെച്ചും എൻ്റെ കയ്യിലുള്ള ഇൻഫർമേഷൻ കൊടുത്തും ഞാൻ അണ്ടിൽ അതർവൈസ് വേറെ ഒരു തേർഡ് പാർട്ടിക്ക് അത് കൊടുക്കാത്തിടത്തോളം കാലം ആ ഡേറ്റയ്ക്ക് ഒരു നഷ്ടവും യാതൊരു രീതിയിലുള്ള സെക്യൂരിറ്റി ഇഷ്യൂസും പ്രൈവസി കൺസേൺസും ഒന്നും വരരുത്. നിങ്ങൾക്കറിയാവുന്നറിയില്ല, ഇപ്പം ഈവൻ നമ്മളൊക്കെ പലരുമായിട്ട് സംസാരിക്കുന്ന സമയത്തൊക്കെ ചിലപ്പം മൊബൈൽ ഫോണിൽ നിങ്ങൾ റെക്കോർഡ് ചെയ്യാറുണ്ട്, ചില മെയിലുകൾ അവരുടെ പെർമിഷൻ ഇല്ലാതെ നിങ്ങൾ സെൻഡ് ചെയ്യാറുണ്ട്, ചില പിക്ചേഴ്സ് ചില സൈറ്റിൽ നിന്ന് എടുക്കണം നിങ്ങൾ അവരുടെ ഒന്നുമില്ലാതെ നിങ്ങളുടേതായിട്ട് ചിത്രീകരിക്കാറുണ്ട്. അതൊക്കെ ശരിക്കും എത്തിക്കലി ദേ ആർ റോങ്, ദേ ആർ ഒഫൻസ്, അത് പണീഷബിൾ ഒഫൻസ് ആണ്. അപ്പം അങ്ങനെയുള്ള കാര്യങ്ങളൊക്കെ വരും. അതുകൊണ്ടാണ് ഞാനിവിടെ ഈ എടുത്ത പടങ്ങളെല്ലാം ഞാൻ ഉണ്ടാക്കിയ പടങ്ങളല്ല, ഐ ഹാവ് കോപ്പീഡ് ഇറ്റ് ഫ്രം സംവെയർ എൽസ്. അതിന്റെ പ്രോപ്പർ റെഫറൻസ് ഐ ഹാവ് ഗിവൻ ഹിയർ, പ്രോപ്പർലി സൈറ്റഡ്. അല്ലെങ്കിൽ അത് പ്രൊപ്പറേറ്ററി ഇഷ്യൂ ആണ്, എത്തിക്സിന് അഗൈൻസ്റ്റ് ആണ്. നമ്മുടെ പല POs ഒക്കെ ലെവൽ അഡ്രസ് ചെയ്യും. നിങ്ങളുടെ ക്ലാസ് റൂമിലൊക്കെ പോയി നോക്കുമ്പോൾ അറിയാം, there are 12 POs ലിസ്റ്റ് ചെയ്തിട്ടുണ്ട്. ആ പല POസും and you are not in a position to achieve all those POs from the book studies or from library learning or from internet things etc. അപ്പോൾ അതിനൊക്കെ പല തരത്തിലുള്ള ക്ലാസ്സുകളും മറ്റു കോഴ്സുകളും ഒക്കെ നിങ്ങൾ അറ്റൻഡ് ചെയ്യണം. ഓക്കെ, അങ്ങനെ വരുമ്പോഴാണ് അതൊക്കെ അച്ചീവ് ചെയ്യണം. അപ്പം ലെറ്റ് മീ കം ഇൻ ടു ദാറ്റ് സെക്യൂരിറ്റി ആൻഡ് പ്രൈവസി അഗെയിൻ. അപ്പം ഇതൊക്കെ എൻഷുർ ചെയ്ത് കൊടുക്കുക എന്നുള്ളത് ഒരു പ്രൊവൈഡറിനെ സംബന്ധിച്ച് വളരെ ആവശ്യമാണ്. So it is a still, and this particular item faces so many challenges in the field of IoT, that in the sense it is important to develop and implement robust security and privacy measures to protect IoT devices and the data collected. I think that particular sentence is very clearer for you. ഒരു എക്സാമ്പിളൂടെ പറഞ്ഞ് ഞാൻ അടുത്ത സ്ലൈഡിലേക്ക് പോവാം. സെക്യൂരിറ്റി റിലേറ്റഡ്. ഇൻ 5 years ago നമ്മൾ ഈ ബാങ്ക് ട്രാൻസാക്ഷനും അല്ലെങ്കിൽ അങ്ങനെയുള്ള പല കാര്യങ്ങളൊക്കെ നടത്തുന്ന സമയത്ത് ഈ മൊബൈലിൽ OTP വരുന്ന ഒരു സാധ്യത വളരെ കുറവായിരുന്നു. And nowadays 2-step verifications are possible even in our mail itself. If in WhatsApp or similar platforms it is available. In case if you wanted to entrust that much double security, and you can even provide that OTP platform, mobile OTP, അതേപോലെ മൊബൈലിലേക്ക് OTP ഒക്കെ സെൻഡ് ചെയ്യാനുള്ള പ്രൊവിഷൻസ് ഉണ്ട്, and they are sending that particular message to the mobile where that particular mobile number you have provided or you have stored. അതിലേക്കാണ് വരുന്നത്. അപ്പം അതൊക്കെ ഈ സെക്യൂരിറ്റി ആയിട്ട് ബന്ധപ്പെട്ട കാര്യങ്ങളാണ്. അപ്പം അങ്ങനെയുള്ള കാര്യങ്ങളെ അഡ്രസ്സ് ചെയ്യുക എന്നുള്ളത് ഈസ് എ ചലഞ്ചിങ് ടാസ്ക്, and there so many researchers are progressing, and as engineers we have the responsibility, IoT engineers, we have the responsibility to solve these challenges. So similarly complexity, ആരും ഒരിക്കലും ഒരു സർക്യൂട്ടിനെ അല്ലെങ്കിൽ ഒരു കോഡിനെ കോംപ്ലക്സ് ആക്കില്ല. ഇപ്പം ഇൻ അവർ ലാബ് അസ്യൂം ആൻഡ് ഐ ഹാവ് അസ്യൂം ഐ അസൈൻഡ് യു ടു ആഡ് 2 8-bit നമ്പേഴ്സ്. അപ്പം ഏറ്റവും സിമ്പിളായിട്ട് ആ പ്രോഗ്രാം ചെയ്യുന്ന ആളാണ് അതിനകത്ത് റിയൽ എഞ്ചിനീയർ എന്ന് പറയുക. അല്ലാതെ അതിൽ പല രജിസ്റ്റേഴ്സ് യൂസ് ചെയ്ത് ലൂപ്പുകളെല്ലാം കയറ്റി മാറ്റി ഇറക്കി അങ്ങോട്ടും ഇങ്ങോട്ടും എല്ലാം കോപ്പി ചെയ്ത് ചെയ്യുന്ന സമയത്ത് ആൻഡ് യുവർ കോഡ് വിൽ ബിക്കം സോ മച്ച് കോംപ്ലക്സ്. Complex in the sense, whenever the line number increases, what happens? The processing time also increase. In that microcontroller era or in electronic era, a microsecond or a nanosecond, a time is very precious. And these are the challenges currently facing in this particular IoT field. Scalability, I have already shown in the very first slide itself that one of the major characteristics of IoT is a scalability. In that scalability point of view, even then that IoT is scalable, there also a couple of challenges are there. Couple of challenges in that scalability field is there in what you call that whenever we are dealing with a high volume of data, we cannot achieve that much scalability in that IoT. And then similarly standardization is also a challenge, and obviously the cost of that smart sensors, smart processes, and smart cloud, and smart implementation, etc are heavy, costlier when compared with that conventional system. So and by manufacturing a very mass of devices, and we can even reduce the cost to that particular level. So these are a couple of major challenges faced in the field of IoT. And these are a couple of very good data website or e-resources, and they are available in the field of IoT. When time permits, I request all of the IoT enthusiasts to go through this particular website. Very good information is available. When time permits, please go through. And these all are self-explanatory only. I don't like to get into each site one by one. Anyway, based on your interest, please do select the suitable one and get into that and find out the what you call that required information out of there. And in case much more understanding is there, and deviate from there and go search and proceed. And then this is a future of IoT. I told you, in the third slide itself that in 2025, around 76 billions of devices are being connected, or 75 million devices are being connected virtually under the umbrella of IoT. So, and this is what is a future, and increased adoption of IoT in all industries and sectors. I told you that human intervention is going to be reduced. Without any human intervention, we are going to handle that IoT devices. And another area, development of new IoT applications and services. And then so many technologies, booming technologies are available. So many types of IoT based on categories we have seen. And nowadays, artificial intelligence and machine learning, then as well as deep learning, so many other platforms and is being coming to picture. So there also we can incorporate the facility of that IoT. And then I told you, and security and privacy is a challenge. Even then, so many type of content should be addressed. So this also comes under the future of IoT. So this is a last title. I think I have taken around 1 hour. Sorry, I have exceeded 5 more minutes. I agreed you to finish up my presentation within 45 minutes. So the conclusion is nothing but I believe I have given you a very fundamental overview of IoT. And exactly from the embedded system we have started, we differentiated an embedded system with an IoT devices, and then we came across the roadmap or the history of IoT, major milestones as well as major inventions, and after that, and we have seen how many devices are being connected in a couple of years ago, and what about the expectation of major forecasting agencies of that IoT related devices, that also we have discussed. And then major shares of IoT in various sectors are also we have seen. And after that, we have seen the different elements involved in that particular IoT structure. The layers involved in that IoT also we have gone through, and 4 layers was there. And after that, that connectivity solutions were also discussed, and couple of use cases, application areas were also described based on different application scenarios. So many names are possible for IoT, that also we have seen. And at the last part, we have seen a couple of challenges that is being currently faced by, or that is currently facing in the field of IoT, and the future directions are also being discussed very fundamentally. And that is the end of my presentation. And thank you all for your patient listening. Thank you. Hello. Hello, the coordinators. Over to you. Let me stop presenting.
Is anyone having any doubts? ആർക്കെങ്കിലും എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ? സാറിനോട് നേരിട്ട് ചോദിക്കാം, കുഴപ്പമൊന്നുമില്ല, നമ്മുടെ സാറാ. എന്തെങ്കിലും ഡൗട്ട്സ് ഉണ്ടോ? ആർക്കെങ്കിലും എന്തെങ്കിലും ക്ലിയർ ചെയ്യാനുണ്ടെങ്കിൽ ഇപ്പൊ ചോദിക്കാം.
I told you, this is a very basic element only. I believe I have done my job effectively. I believe that. Just fundamental only. The students who are from S8 or S5, they are in a better position to elaborate the concept technically. Very well done me. But and I have given you a foundation, preferably to the first year as well as to the third semester students. And if you could make a clear understanding about this foundation, I'm sure that in the upcoming weeks, and you can easily follow all other points, and they are going to elaborately, and they are going to clearly given you with a little bit deep knowledge about each part that I have shared here now. I believe no further queries from audience. So, Anne, shall we stop now?
Yes, sir, we will conclude now.
Thank you.
Good evening, everyone. On behalf of our team, I would like to extend a heartfelt vote of thanks to everyone who made this event possible. First and foremost, I would like to thank God Almighty for showering His blessings. Next, I thank our session handler, Dr. Arun P., our HOD, who took his precious time to expand our knowledge. Thank you, sir. Next, I thank our organization and our team for helping us in organizing the event. Last but not the least, I thank all the participants. Hope it was a useful session. Thank you.
Thank
Thank
you.
you, sir.
Good night. Thank you. Bye.
Good night, sir.
Night. Good night.
എല്ലാവരും പോകുന്നതിന് മുമ്പേ നിങ്ങളുടെ അറ്റൻഡൻസ് ഒന്ന് ചാറ്റ് ബോക്സിൽ ഇടുവായിരുന്നെങ്കിൽ വളരെ നല്ലതായിരിക്കും. നിങ്ങളുടെ ഫുൾ നെയിം വെച്ചൊന്ന് ഇടുക.